This story dates back to 2006 when scientists from around the world detected a toxic gas in our atmosphere, methane gas. It was observed that the amount of methane in the atmosphere had suddenly increased significantly and was continuing to rise. Methane is a type of natural gas that, when released into the atmosphere, heats the Earth. Just as we cover ourselves with a blanket to stay warm in winter, this gas acts like a blanket around the Earth. The heat inside stays trapped, making the Earth even warmer. Methane gas is far more effective at trapping heat than carbon dioxide. When it started increasing suddenly in 2006, scientists initially thought it might be due to pollution caused by human activities, but what they discovered after investigation left everyone stunned. It was a great mystery hidden within our Earth. How was this methane gas being produced, and why was its quantity continuously increasing? How does the scientific community detect methane gas, and most importantly, is this methane gas a sign of the world's end or an indication of a major climate shift? Dear viewers, the scientific community already knew that a spike in atmospheric methane typically occurs once every 100,000 years. This information is obtained by drilling in icy regions like Antarctica and Greenland to extract ice cores. Imagine that every year, 1 meter of snow falls in Antarctica. This snow traps the air from the atmosphere, and the next year, a new layer of snow covers it. When deep drilling extracts an ice core, it holds a record of the atmosphere from thousands or millions of years ago, like a time machine. From this, scientists estimate which gases were present in the atmosphere in which century, and in what quantities. This way, the scientific community discovered that in Earth's history, every 100,000 years, there comes a point when methane gas in the atmosphere becomes very high. This is a sign that an ice age is ending, and the Earth will start warming again. When an ice age begins to end in just 2,030 years, much of the ice melts, and the Earth's condition becomes like today's climate. But the problem here is that such methane levels were recorded 12,000 years ago, after which the ice age began to end. So why is methane rising again in the atmosphere so soon? Is our Earth heading toward a major change, or is this a new danger? To understand this mystery, we need to look at Earth's history. We are currently in a phase called the Quaternary period, which began about 2.5 million years ago and continues today. This Quaternary period has two parts. The first part was the Pleistocene epoch, which ran from about 2.5 million years ago to 12,000 years ago. During this period, ice ages repeatedly occurred, covering large parts of the Earth with ice. Then thousands of years later, the ice would melt, and most of the Earth would become habitable again. The cycle continued like this. This was the era when humans evolved, and large animals like mammoths went extinct. Then came the second part of the Quaternary period, called the Holocene epoch, which began about 12,000 years ago and continues today. In this period, ice significantly reduced, and the Earth's climate became much more stable and warm. This allowed humans to learn agriculture. Melting glaciers created freshwater resources, and humans began settling villages near water sources. Now there's a small confusion here. We are in the Holocene, which is a warm period, but technically we are still in an ice age. This means there is still ice at the Earth's poles. However, these glaciers are not as large as they were at the peak of the ice age. Only when there is no ice at the poles can we say the ice age has truly ended. But the question is, what is it that warms the Earth and ends an ice age? The scientific community has identified three major factors known as Milankovitch cycles. The first is eccentricity, meaning the Earth orbits the Sun in a circular path. But sometimes this path or orbit becomes slightly oval-shaped. In this oval shape, when the Earth reaches a certain point, the heat received from the Sun increases. This eccentricity cycle lasts about 100,000 years. During these 100,000 years, the orbit goes from circular to oval and back to circular. However, the scientific community believes that not only the eccentricity cycle but also axial tilt plays a significant role in ending an ice age. This means that when the Earth orbits the Sun, it is slightly tilted at about a 23.5-degree angle. But this tilt changes slightly over time. When the Earth is more tilted, the poles receive more sunlight in summer, and the ice there melts faster. Scientists believe this cycle lasts about 41,000 years, during which the Earth tilts between 22.1 and 24.5 degrees. The third factor is precession, or the wobble of the Earth's axis, like a spinning top. This changes the timing of seasons. This cycle lasts between 19,000 and 23,000 years. These three factors, eccentricity, axial tilt, and precession, together start a cycle that warms the Earth. Ice reflects most of the sun's light, but when white ice melts, the land or ocean beneath it is exposed to sunlight. And its color is not white but dark, like the color of soil or the dark blue of ocean water. Everyone knows that dark colors absorb sunlight well. When more absorption occurs, more ice melts and this cycle continues. But the Earth starts warming significantly when gases trapped in the Earth, like carbon dioxide or methane, begin to be released into the atmosphere due to the heat. These gases are trapped in oceans or in frozen ground called permafrost. Their release makes the Earth even warmer. So, the question now is, if everything was fine, why was there such a large increase in methane in 2006? The Ice Age-ending event happened just 12,000 years ago, not 100,000 years ago as is typical. In the 1900s, when the natural gas industry grew rapidly, methane emissions due to human activities also increased significantly. But by 1990, they stabilized at a certain level. So where did this new spike in 2006 come from? Methane is a gas produced not only by human activities but also naturally. As I mentioned earlier, gases hidden in the Earth are trapped in wet soil and oceans, and melting ice acts as a trigger point. With today's advanced technology, scientists can identify where these gases are being released from. This involves sending a specific wavelength laser beam from a satellite to the Earth. Only methane gas can absorb this wavelength. If the laser light does not reflect back to the satellite, it means methane gas has absorbed it at that point. This way, the scientific community has created a global map of methane. Using this technology, NASA teams mapped a 3-mile-long methane cloud over a large landfill in Iran. It releases 73,440 tons of methane gas into the air every year, equivalent to the weight of 180 Boeing jumbo jets. In terms of hours, that's 8,500 kilograms per hour. But even more methane is being released from Turkmenistan. At oil and gas production sites there, 12 points were found where about 400 kilograms of methane is released into the atmosphere every hour. However, the scientific community believes that the methane spike after 2006 is not solely due to this. It's not even half of it. A large portion is being released from forests, especially those previously on permafrost. Now, as permafrost melts, fossils in the ground decompose rapidly, releasing methane gas, which is causing the methane spike. The biggest problem with methane gas is that once it mixes with the air, collecting it is very difficult. Collecting methane from landfills or gas fields is relatively easy, but gas released from forests cannot be collected. Even in many modern landfills, methane gas is collected and used for energy generation, producing carbon dioxide as a byproduct, which is dangerous but less so than methane. Methane gas can remain in the atmosphere for up to 10 years before turning into carbon dioxide and water vapor. The issue is that although such methane levels have been detected before, like 12,000 years ago, whenever the Earth released so much methane, it was during the end of an ice age. At this time, when glaciers have already melted significantly, such methane levels have never been seen before. Perhaps this is an indication that the Earth is moving into a new phase. But to be honest, it's very difficult to predict what will happen, whether the ice age will completely end, or if we are heading into a new one. Because the scientific community has no clear reference point in Earth's history showing methane levels rising so much just 12,000 years after the last spike. We also don't know how high these levels will go, and if this is indeed happening naturally, rather than due to human causes, stopping it is impossible.